Now we can use this law of sines when we see an oblique triangle, an angle that's not, or a triangle that's not a right triangle, and if we know two angles and a side. So an example I have for you right here, I have an oblique triangle, not a right triangle. Two angles are listed and one side is listed. Given that amount of information, I can find all of the remaining angles and the lengths of the remaining sides. So let's try this out here a little bit and find out what's going on. First of all, we can find out what angle B is fairly straightforward. Because remember, the sum of the interior angles of any triangle equals 180 degrees. So if we can find out what the remaining one is here, 46 plus 63 is 109, and 109 take away from 180 gives me 71. Whoops, not 17. 71 degrees. And let me just double check that to make sure. 109 plus 71 equals 180 degrees. Okay, from that, let's use our law of sines to figure out some information we have. And so again, I can take any two of these three ratios to use. And notice that I wrote one version where I have the sign in the denominators and another version where I have the sign in the numerators. And you can use whatever version that you want. Both of these are equivalent due to the rules of algebra that we become so good at using. So let's look at A over the sine of A equals C over the sine of C. So this is going to find out this unknown, that side right there. So I would have A over the sine of 46 equals C, which is a length of 56, all over the sine of C, which is 63. Solve that equation for A. Basically means that A will equal 56 times the sine of 46 degrees, all over the sine of 63 degrees. Now, since those are not the angles that I'm familiar with, those aren't the magic 16 angles, I'm going to use my black box. I guess I'm going to use my yellow box to solve that. First of all, I'm going to make sure I'm in degree mode. And so I'm going to go 56 times sine 46 divided by sine 63. Hit enter, and I get 45.2 inches. So the length of A is 45.2 inches. And I'll just do the process one more time to find this length of B over here. So let's take the ratio of the side of B to its angle. And let's do C again, this is fine. C all over sine of C. So, oh, sorry, and we know what sine of B is, so let's write it. B sine of B. B is 71 degrees. And C is 56. All over the sine of C, which is 63. Solve that for B. So B will equal 56 times the sine of 71 all over the sine of 63. And then once again, using the evil black box, 56 times sine 71 divided by sine 63 gets 59.4 degrees. Or sorry, not degrees, 59.4 inches. And that's reasonable because if I look at that, 71 is the largest, angle B is the largest angle, which would produce the largest opposite side. And so that was just a quick little bit of a reasonable check to see if those answers look good.